Alaikum. Following our earlier lesson in which we have discussed the past paper MCQ 21 to 40. In this lesson, we are going to discuss the remaining 20 MCQs inshallah. So starting with the MCQ number 20, it says the motor of a crane lifts a load of mass 600 kilograms. The load rises vertically at a constant speed of 12 meters per minute. And since we see that the final answer is in watt and kilowatts, so we know that this velocity does not have to go in meters per minute, it has to be in meters per minute, meters per second. If it is 12 meters per minute, it would be 12 by 60 meters per second. Now, what is the useful power output of the motor? Power is the product of force and velocity, right? The force the motor has to apply to keep the object or to lift the object vertically upward, the applied force would equal the weight of the object, right? Because the weight is vertically downward, we'd write mg into the velocity here. Mass is 600, 9.81 gravity, and the constant velocity of 12 over 60. So let's put these values in your calculator and you'll get your final answer in watt. And you take 1000 common, or maybe you divide it with 1000 to get the final answer in kilowatts. And the final answer comes out to be 1177. In kilowatts, we'd say that it is 1.17, which would be rounded off to 1.2 kilowatts. Then it says the diagram shows a block on a slope which is inclined. A constant force of 1.8 Newton in a direction parallel to the slope is exerted on the block. This causes the block to move along the slope at a constant speed. The block moves a distance of 8 meters along the slope and gains height h. The work done against the frictional force acting on the block is 4.8 joules. The weight of the block is 4 Newton. What is the value of height? Now, in order to answer this question, you should be able to establish that the applied force of 1.8 Newton ये दो काम कर रही है. एक तो इस अप्लाइड फोर्स की वजह से जो एनर्जी इन्वेस्ट हो रही है यहाँ पर, वो दो कामों के लिए जो है वो यूटिलाइज हो रही है. एक, इट इज डूइंग सम वर्क टू ओवरकम द फ्रिक्शनल फोर्स, एंड देन दूसरा, इट इज डूइंग सम वर्क टू lift the object through this certain height h. So first we are going to find कितनी energy invest हुई थी, right? So work done by the applied force F should be the applied force F times the displacement in the direction of force, right? Applied force was 1.8 and the displacement traveled in the direction of applied force was 8. So let's multiply these two. We'll get 14.4 joules of work that is done, right? And then इस 14.4 में से जो 4.8 joule है, it is utilized to overcome the frictional force. So 14.4 में से 4.8 was utilized to work done against the frictional force. इसका मतलब है बाकी का 9.6 joule is the work which was utilized in lifting this object through this height h. If the work done to move an object along the height h was 9.6, this should equal the force as well as the displacement, which in this case is this height, right? So we have to place this height. Now, whenever we use the formula for work done, we know that the force and the displacement जो आप उस formula में use करो, यानी जो हमारे case में जो height है, the force and height should be along same directions. Height is vertical. The force that must be required in this case would be along vertical, which is the weight of the object. right? So in this case, instead of writing this force here, we'd place the weight of the block, which they have provided us, kind of force, is 4 Newton. So we'd say that 9.6 is equals to 4 times h, and dividing these, you can get the value of height, which is nothing but 2.4 meters. Then a ball falls towards the ground from point X. Point X is 2.4 meters above the ground. 2.4 meters. This right here is this point X. The ball rebounds from the ground. The ball falls, it rebounds from the ground and it rises to a point Y. And this point Y is 1.8 meters above the ground. A single value of the change in height is used to calculate the change in gravitational potential energy of the ball from Y to X. What is the magnitude of change in height? The magnitude of change in height is, of course, the difference between these two. It has to be 2.4 minus 1.8. So the final answer of this question would be 0.6, because potential energy may we'd have mgh, and mg, which is the weight of the ball, it remains the same for when it was moving towards the ground or when it rebounces from the ground, right? So mg का factor तो यहाँ पर exclude हो जाएगा. Potential energy के लिए the only thing that would be required would be the difference of the initial and final height, that is 0.6 meters. Option A is correct option. Then a student attempts to write the formula for kinetic energy. She begins by considering an object of mass m that is initially at rest. A constant force F applied to the object causes it to accelerate to final velocity v in displacement s. Kinetic energy gained by the object is equal to the work done by the on the object by the force F. Now, which equation does the student not need in order to drive the formula for kinetic energy? Kinetic energy के लिए she'd, because it is a kind of energy, right? So she'd start with energy, which is a form of work done. Work done is force into displacement, and force would be the product of mass and acceleration. And then acceleration की value she'd place using this equation, because kinetic energy comes in velocities and हमें जो value चाहिए acceleration की चाहिए, so this value would be used for interchanging the velocities into accelerations. This equation would also be used. The only equation that would not be used in order to drive the equation is this equation. So they've asked which would not be used, hence the correct option is option C here. Now, on Earth, a solid object that is fully submerged in a liquid experiences an upthrust force. And on Mars, the same object fully submerged in the same liquid experiences an upthrust force um. The acceleration of free fall on Mars is 3.7. Now you assume that the liquid's density remains the same and the object's volume also remains the same on Earth and Mars. Now what would be the ratio for upthrust forces? Upthrust force on Mars over upthrust force on Earth. What is the formula for upthrust force? It's rho gv, right? So the density on Mars, gravity of Mars, volume displaced on Mars. And for Earth, the density of Earth, gravity of Earth, volume of the object, volume of the liquid displaced on Earth. They said that the density is same on Mars and Earth, दोनों same होकर cancel हो जाएंगी. They said that the object का volume and hence the volume of displaced liquid is same on Earth and Mars, वो भी cancel हो जाएगा. इसका मतलब है the ratio of thrust on Mars over thrust on Earth should equal the ratio of gravity on Mars over the gravity on Earth. Gravity on Mars, they've said it is 3.7. Gravity on Earth, we know it is 9.81. So you simply have to divide these two and you would get the final answer, which comes out to be 0.377 rounded off to 0.38, and hence the correct option is option A. Or Then the mass and volume of an object are varied, which two changes when made together must increase the density of object. Density is mass per unit volume. If you do want to increase the density of object, you have to increase the mass and you have to decrease the volume. हमेशा रेशियो का फाइनल आंसर कब बढ़ता है? जब आप न्यूमरेटर को इंक्रीज करते हो और जब आप डिनोमिनेटर को डिक्रीज करते हो, राइट? सो वी नीड टू इंक्रीज द mass and we need to decrease the volume. That is the final answer is option C. First 20 तो बहुत easy है, you should be able to solve them. चलें, I'll give you a question or two to solve yourself as well. The diagram shows a uniform bar of mass m and length L, and it is resting on a pivot at a distance x from end x. An object of mass m is placed on the bar at a distance y. Abhi tak we do not know that where this distance y, where this object would be placed at a distance y. Like they didn't even tell us if it is on the right side or the left side, right? So that the bar is in equilibrium, what is an expression for y? Now, this object itself is uniform, and uniform objects always have their weight acting as a force at the center. तो इसका मतलब है it is as if यहाँ पर center पे एक weight पड़ा हुआ है and जिसकी value है capital M. अगर यहाँ पर एक weight पड़ा हुआ है and उसके बाद भी this object appears to be in equilibrium, this would only be possible if there is an object on the other side. So let's just say randomly यहाँ पर कहीं वो object पड़ा हुआ है and they said that the y is the distance of that object from pivot. इसका मतलब है this distance then would be y. Now we have to write a formula for y since they've said that when the object is placed at y, the rod will be in equilibrium, and for equilibrium, the sum of clockwise torques should equal the sum of anti-clockwise torques, right? Yani right पे force into moment arm should equal left पे force into moment arm. So let's first see for the weight that is acting here, the weight of the rod itself, right? And क्योंकि it is vertically downward, it will generate a torque that is clockwise. So let's place यहाँ पे clockwise torque की जगह इसका expression. It would be force times the moment arm, right? And the force is the weight of the rod, which they have mentioned that is capital M. And then we'd write the moment arm, that is the distance of this weight from the pivot. This distance we have to write, right? मुझे नहीं पता directly ये distance क्या है, but मुझे ये पता है कि this distance is half of the length because weight exactly half पर act करेगा for uniform object. This is L by 2. This distance is x and मुझे चाहिए ये वाला distance, right? The distance of the point at which the weight is acting to the pivot. So what we can do is L by 2 में से x को subtract कर दें, you will get your distance जो आपको यहाँ पर place करना है. I can write L by 2 minus x. And जो यहाँ पर अब हमने weight place किया है, downward act कर रहा होगा. Clear? It would generate a torque that is anti-clockwise. इसके लिए expression यहाँ पर लिख लेते हैं. We'll write the weight that is placed here as a force. This weight they've said is m. ठीक है, मैं क्यों weight की जगह mass place कर रही हूँ? यहाँ पर भी m into g आ जाता and यहाँ पर भी m into g आ जाता. That is weight जो हम force की जगह place करते हैं and g would have cancelled with g. राइट, सो मैं ये जी वाला पॉइंट बस स्किप कर रही हूँ, आप लिखते भी तो वो कैंसिल हो जाता. एंड देन दिस weight multiplied by the moment arm, that is the distance between this point and this point, which they've already mentioned, that is y. So I'd place a y here and we have to make a expression for y, so y को एक तरफ रखें, बाकी सबको दूसरी तरफ ले जाएं. You would have m divided by small m, L by 2 minus x. Now you can see we have m over m, m over m in these expressions, but we don't have L by 2. Instead, we have सिर्फ L, right? हमारे expressions में. So what we can do is हम इस equation को एक step मजीद simplify करेंगे so that our final answer matches the one that is given in any of these options, right? तो मुझे यहाँ से इस half को हटाना था. So what did I do was I took this 2 from the denominator common. मैंने इसे बाहर निकाल लिया. जब यहाँ से 2 कॉमन गया, पीछे क्या बचेगा वो आपको हमेशा पता चलता है जब आप जो भी वैल्यूज थी उनको जिस जिस भी वैल्यू को आपने कॉमन लिया उससे आप मल्टीप्लाई करवा दें. यहाँ से मैंने 2 को कॉमन लिया है ना, यू मल्टीप्लाई दिस विद 2, यू मल्टीप्लाई दिस विद 2, आपको पता चल जाएगा पीछे क्या बचना चाहिए. नाउ दिस 2 गेट्स कैंसल्ड विद दिस 2, यानी पीछे सिर्फ L बचा, एंड देयर इज नो वन टू कैंसल दिस 2, यानी यहाँ पर पीछे आपके पास 2x बच जाएगा, राइट? So the correct answer would be m over 2m L minus 2x. They just went on ahead with another step for this simplification. Otherwise, this also would have been a reasonable answer. In this case, option C is the correct answer. Then which diagram shows a couple? Couple is whenever there are two forces that are acting on two different points and they are somehow supporting each other, which usually happens when they are working in two different directions. Consider of that like you have both of your hands placed on a steering wheel, and see both the hands are placed on two different points, pivot के एक right side पे and एक दूसरा left side पे, and one hand moves rotates clockwise, the other rotates also clockwise, but you would feel like one hand is moving downward and the other is moving upward, but eventually both the forces applied by both the hands, they are supporting the same motion, that is the clockwise motion in that anti-clockwise motion in that specific case maybe, right? So a couple has to have two forces acting at two different points. See, two forces acting at two different points. 1, 2, 3 तीनों correct option हो सकते हैं. D बस correct option नहीं है इस हिसाब से. Then these two forces must be in opposite direction supporting each other. यहाँ पर देखें, they are in same direction, they are not supporting each other. However, in case A, they are in opposite direction and they support each other. Like if you exert a force at this end, trying to move it downward, and you exert a force at that end trying to move it upward, both of these forces are going to support the anti-clockwise motion of this rod, right? So this is what a couple does. Correct answer is option A. Abhi tak I did not give you a question to solve. Let's solve this question. We have two different blocks, P and Q. They slide towards each other on a horizontal frictionless surface. The blocks have elastic collision. That is when we say elastic collision, iska matlab hai the conservation of momentum should follow and the kinetic energy of the system, that is the sum of P ki kinetic energy and Q ki kinetic energy before the collision should equal after the collision, right? And you have to find the possible velocities of these blocks right before the collision. You'd apply the conservation principle here. Then a skydiver is falling at constant velocity. She then opens the, she was falling with constant velocity. She then opens her parachute. The graph shows the variation with time of her velocity. Now, which statement about the motion of a skydiver are correct? The magnitude of acceleration is maximum at t2. Yes, पहला correct point तो मिल गया, because velocity time graph का slope gives us acceleration, right? At this point t2 the slope is maximum, so this means option 1 is correct. The magnitude of the drag force at time t1 equals the magnitude of the drag force at times t2. That is also correct. The magnitude of drag force is maximum at t1. No, at t1 it was not maximum. She has opened the parachute at time T2 के बाद, right? So that is when the area would have increased and so would have the drag, right? So the correct answer would be option 1 and 2, that is the option A. Then the diagram shows the view from above of two balls moving along a horizontal frictionless surface before they collide. The momentum of each ball is also shown. The balls stick together during the collision. Which vector diagram represents the combined moment of ball after the collision? This is before they collide, and after the collision they stick together. Now first of all, what we have to do is we have to find the total momentum before collision, right? Let's say there's one, and then using the rule for vector addition, head to tail rule, we have the total momentum of the system, which turns out to be this one before collision, and we have to comment on the total momentum of the system after the collision, right? And after the collision, the two balls stick together, they'd have the same momentum जो पहले था. That is the total momentum which was before collision. This would be the total momentum after the collision as well, combined momentum. The option B is the correct option. Then what is the statement of principle of conservation of momentum? In an elastic collision, momentum is constant. Momentum is product of mass and velocity. Force acting on a body is proportional to its rate of change of momentum, and the momentum of an isolated system is conserved. Of course, this right here is the statement for conservation. Now, which statement describes the weight of an object? It is equal to the mass of object multiplied by its acceleration. It is equal to the resultant force when the object falls with terminal velocity. We can say this, but then let's see baki ke options, because that does not necessarily have to be true. In a few cases, yes, but that is not how we describe it. It is the force acting on the object due to the gravitational force. It is the property of object that resists the change in motion. That is mass that resists the change in motion. And the correct option would be option number C, because that is how we describe weight. We say that the weight is force of gravity on an object. And then the velocity time graph for an object is shown, which expression gives the total displacement of the object. We have studied that the area under the velocity time graph, it gives us displacement, right? So एक displacement ये होगी, and then एक displacement ये होगी. The resultant displacement or the total displacement would be the difference of these two. Had they been in the same direction, तो हम इसको add करके total displacement निकालते हैं. But because they are in the opposite direction, that is, it's like an object started, it moved to a certain distance, and then it is started back. So resultant displacement फिर हम ऐसे निकालते हैं, right? Yani we take the difference of both the displacements. So this is the same thing we are going to do here. We are going to find the area of one, and then we subtract the area of two to get the final answer, which would give us the resultant displacement. That is option A is correct here. Then a bicycle brakes so that it undergoes uniform deceleration from speed of 8 to speed of 6. And initially it was 8 and finally it was 6. Its velocity decreased at a constant rate over a distance of 7 meters. यानी 8 से 7 तक आने के दौरान जो distance travel हुआ, it is 7 meters. The deceleration remains constant. Which further distance will the bicycle travel before coming to rest? आपसे कह रहे हैं कि इतना डिस्टेंस ट्रैवल किया, वेलोसिटी 8 से कम होते होते 6 पर आ गई. अब जो इस दौरान एक्सेलरेशन था, वही सेम एक्सेलरेशन या वही सेम डिसेलरेशन ऑब्जेक्ट जो है वो एक्सपीरियंस कर रहा है. अब आप मुझे बताएं कि फाइनली इसकी स्पीड 6 से कम होकर 0 पर जाने में ये मजीद कितना डिस्टेंस ट्रैवल करेगी, right? While the acceleration in both the cases remain same. So मैं क्या करूंगी, पहली इंफॉर्मेशन से पहले acceleration निकालूंगी, and then I'd use this same value of acceleration with this data to find the value of s. So let's quickly do this. Let's use 2as equals b square minus u square and find the final answer. 6 square 36, 8 square 64 over 2 times the distance, which is 7. So we have 36 minus 64 over 14. This gives us minus 2, yani the acceleration is 2 meters per second square. Now we are going to use that 2 meters per second square here and we'll find the final answer. Kitna distance travel hua, again using the same formula, but this time we'd keep s as the subject of our equation and we'll send 2a to the other side. So final velocity is of course 0 minus initial velocity is 6, square would be 36 over 2 into acceleration. Acceleration is, which is deceleration, minus 2 here, minus 36 over minus 4. This gives us 9. The distance traveled by the object after it had reached a speed of 6 meters per second till it came to rest was 9 meters while experiencing a deceleration of 2 meters per second square. A car has an initial velocity u. The car then moves with constant acceleration a in a straight line through displacement d, and the car finally reaches a speed v, which expression gives the initial velocity of the car. You'd use the same equation and all you have to do is just rewrite it. Find the expression for u. Of course, you keep u to the other side, v square minus 2as, and then आप उसको root करना. A ball is released from start. The distance the ball falls and the time the ball takes to fall the distance are both measured. The percentage uncertainty in the measured distance is negligible. The percentage uncertainty in the measurement of time is 4%. Now, the distance and time are used to calculate the acceleration. Air resistance is negligible. आप acceleration calculate करने में percentage uncertainty calculate करें. We have seen percentage uncertainty in a calculated data. It depends on the raw data. राइट तो पहले तो मुझे ये देखना है कि एक्सेलरेशन कैलकुलेट करने के लिए फार्मूला क्या है, मुझे किस किस चीज की जरूरत पड़ रही है. कंसिडरिंग दैट द ऑब्जेक्ट स्टार्टेड फ्रॉम रेस्ट, it's a free fall motion under the influence of gravity, we can go with Newton जो हमारी equations of motions है, right? Vf is equals to vi plus at and but then उस फार्मूला में डिस्टेंस नहीं आएगा. We can either go with s is equals to ut plus half at square, or we can go with 2as equals v square minus u square, right? So let's go with s is equals to ut plus half at square. Why? Because it is easier for us. The object's initial velocity was 0. This makes this a dire factor go 0. So displacement, जो distance जो हमें calculate करना है, this is its equation. Right? Half is a number. Numbers do not contribute to uncertainty, constant numbers. Now, the percentage uncertainty in calculating the value of acceleration would depend on the percentage uncertainty in distance, which they said is none. Right? In measurement of distance, the percentage uncertainty is negligible. And it also depends on the percentage uncertainty in time, but mind you we have a 2 here and we agreed जो भी power आ रही होगी percentage uncertainty से multiply हो जाएगी, right? So this would have been the formula for percentage uncertainty in a. Distance में they said ना होने के बराबर uncertainty, so acceleration की percentage uncertainty would be 2 times the percentage uncertainty in time, so 2 into 4, this gives us 8%. Which physical quantity could have units Newton second square per meter? Okay, so let's just see. Acceleration, force तो खैर खुद newtons हो जाता, out of option. Momentum Newton per second है, Newton into second है. It is also out of option. So the correct answer is either acceleration or mass. Let's find for mass. Mass is force per unit acceleration. Force is Newton and acceleration is meters per second square. And जब मैं इसको न्यूमरेटर में लेकर आऊँ तो I can write meter -1 and second -2 के बजाय +2. Mass is the correct answer. What describes a set of data with a high precision? We have seen that a data would be accurate when it is closer to the original value, the expected value, and it is said to be precise when the data is closer to each other, right? Data measured using equipment with a small scale division, the data that is close to the accepted value, that would have been accuracy. Data with each value having a low uncertainty, or data with repeats that are close to each other, that is a precise data. What is reasonable estimate of weight of an adult? Weight is mass into gravity, right? So what you can do is, you have been provided with four weights, you divide all of them with g, that is 9.81, and then see जो final answer mass क्या आ रहा है, because मुझे estimated adult weight नहीं पता, लाइक न्यूटन्स में मुझे वैल्यू नहीं पता, बट मुझे केजीज में अंदाजा है, लाइक ऑन एवरेज पर्सन द वेट द mass, जिसको हम यूजुअली वेट कहते हैं, बट दैट इज इन केजी. For average estimate, it I think it has to be between 60 to 80, right? So let's see which value is more reasonable. 7 over 9.81. Let's keep it 10 for easy estimate. This would give us 0.7 kg. 700 divided by 10, this would give 70 kg. Then 70,000 divided by 10, 7,000 kg. And this would then give us this value. So of course the most reasonable value is 70 kg. I hope it made sense to you. Till the next video. Allah Hafiz.